All right, so earlier we did some multiplying of polynomials, and just a quick little review. What we did was we took, let's do something very simple like multiplying a monomial into a binomial. For example, let's say we take 3 times x plus 2. If we distribute that 3 in, what we end up with is 3x plus 6. All right, well, today we're going to do basically the opposite of distributing, putting something in. We're going to take something out. So if we take this binomial, think what could we take from each term? Okay, well, a couple of rules. We have to take the same thing from each term. We only can take what each term has to give up. I call it the honest robber. We're going to steal from every term, but we're going to be honest and fair about it. We have to take the same thing from everybody. All right? So you can see that this term has a 3x, and this term has a 6, which is 2 times 3. So hopefully we can see that each term has a 3 to give up. So we call that our GCF, our greatest common factor. What factor do both these have in common? They have a 3 in common. And if we take the 3 out, well, we can say 3 times what would give us 3x? Well, 3 times x. And 3 times what would give us 6? Well, 3 times 2 would give us 6. So distributive property is putting a factor into every term, and GCF, or factoring by GCF, is taking something out of each term. Okay. And again, we call this factoring by GCF. Factoring means breaking up. Okay, breaking it up into its smallest parts. When you were younger, you did a factor tree. We took 16 and we broke it up into 2 times 8. That was a factor. And then we took 8 and broke it up to 2 times 4. We had another factor. And we took 4 and broke it up into 2 times 2. Like this, we created a factor tree. Okay, well, we're basically doing the same thing with polynomials. Let's take a little more complicated one. Let's go 12x squared minus 3x. Okay, well, again, we could take 12x squared and think of it as 2 times 2 times 3, x times x. We broke it up into its smallest parts, minus 3 times x. Okay, we're looking for the greatest common factor. So what do these two terms have in common? Well, they both have a 3 in common, and they both have at least one x in common. So if we take out a 3x, we call that our GCF. But we always have to keep track. What's left inside? Well, this term, what's left? 4x. Minus sign comes down. And what's left here? You might say nothing, but there's always something left behind. If you take everything, you always got to leave a 1 behind. And now let's check. 3x times 4x is 12x squared. And 3x times negative 1 is negative 3x. That's why you always got to leave that 1 behind. Okay. One other way to think of factoring by GCF, let's go with 16x squared minus 12x plus 24. Okay, and let's see what each of those have to give up. Well, 16 is 4 times 4, and 12 is 3 times 4, and 24 is 6 times 4. Well, you say, well, these guys, we could take a 12 out of these guys. Well, 16 doesn't have 12 to give up. We could take an 8 out of these two guys, but 12 doesn't have an 8 to give up. But you know what they all can afford to give up? They can all afford to give up a 4. Okay, so I'm going to take a 4 from each of them. So another way to think about GCF is if we divided a 4 out of each of these terms. And you notice these two have an x to give up, but unfortunately, third term doesn't have an x to give up. So we can only take 4 from each of them. Remember, we're honest about it. We're going to take the same from everybody. So if the 4 is my GCF, What's left inside? There's two ways of doing it. 16 divided by 4 is 4x squared. And negative 12 divided by 4, or negative 12x divided by 4, is negative 3x. And 24 divided by 4 is 6. And we can always check. 4 times 4x squared is 16x squared. 4 times negative 3 is negative 12x. And 4 times 6 is 24. So we got everything. And that is factoring by GCF. So let's do a couple of these together. Now again, that box method might be handy because sometimes you want to think about working backwards. All right? If this was our binomial, well, what could each of these give up? They both have a factor of 3, and they both have an x. So let's take out a 3x. Well, 3x times what would give us 3x squared? Well, 3x times x. And 3x times what would give us 15? Well, 3x times 5. So what we're saying is 3x times x plus 5 equals 3x squared plus 15. The 3x is our GCF, our greatest common factor. Both of these share a 3x. Take it out, and what's left over? X plus 5. Okay, let's jump down here and let's do a few of these together. All right, let's look at number 4. Well, if you have trouble with this, break these up into the smallest part. 12 is 2 times 2 times 3, and 28 is 2 times 2 times 7. And of course, there's j to the third, but 28 doesn't have any j's. Well, if you'll notice, they both have two 2's to give up. 2 times 2 is 4. If we take those out, what's left? 3j to the third plus 7. Check your work. 4 times 3j to the third is 12g to the third, and 4 times 7 is 28. Okay? Now, the better you are at multiplying, the easier this gets. Let's jump over here to number 6. All right, well, let's see. What do they all have to give up? Looks like they all have at least a 3 to give up, and only a 3. So 3 times what would be 12k to the third? Well, 3 times 4k to the third. Minus sign comes down. 3 times 3k squared equals 9k squared. And 3 times 2 is 6. So I kind of like to work backwards. Once I figure out what my greatest common factor is, I work backwards to find out what's left over. Okay? Now, some people like to do the division method, which works as well. I notice that 4 times 8 is 32, and 8 times 10 is 32. So maybe 8 goes into all of those. So let's take an 8 into each of those. Now I also notice they all have at least 2 z's. This one has 4 z's, this one has 3 z's, and this one has 2 z's. Remember, I'm an honest robber, so I'm going to take the same from everybody. Oops, that's a z. All right, so 32, so my GCF is 8z squared. So I have to figure out what's left in. 32 divided by 8 is 4. And if I take 4z and I subtract 2, I'm left with z squared. Because remember, 4 minus 2 is 2. Minus sign comes down. 80 divided by 8 is 10. 3 z's, or 3 minus 2 is 1z. And then 112, 8 goes into 112 14 times. So plus 14, and 2 minus 2 is 0, so it's just 14. Okay, so we've done our GCF. And I purposely missed something. And that's why it's always important after you do GCF is to look back inside. Did I miss anything? Well, you know what? I noticed each of these has an even number. 4 is 2 times 2, 10 is 2 times 5, and 14 is 2 times 7. So I left a 2 behind. That's okay. I can just take a 2 from each of them. And I have to bring it outside. So 2 times 8 is 16z squared. 4 divided by 2 is 2z squared. Negative 10 divided by 2 is 5z, and 14 divided by 2 is 7. So I know it's kind of small, but my GCF was 16z squared, and what's left inside? 2z squared minus 5z plus 7. All right, let's jump down to number 12. All right, so 1 times 13 is 13, and 3 times 13 is 39, so I'm taking out a 13. This guy has 1c, and this guy has 2, so I get to take 1 from each. This guy has 3 d's, and this guy has 2 d's, so I'm taking 2 from each. Remember, I want to take as much as I can as long as I take the same. All right, so 13 times 1 is 13. I can put the 1 if I want or leave it off. C times 1 is c, so I don't need anything there, but d squared times d is d to the third. Okay? 13c times 1 is 13c, d squared times d is d to the third. Plus sign comes down. 13 times 3 is 39, and c to the first times c to the first is c squared, and the d squared is already taken care of, so you're done. All right, now of course we always got to make things a little tougher, so we got to look at the big picture here. Let's look at this, factor out the greatest common factor of each expression. Well, let's look at this big thing right here as a binomial, this whole thing as a binomial. And this is our first term, and this is our second term. Well, what do our first term and our second term have in common? They both have an x plus 5. This is x plus 5 squared, or x plus 5 times x plus 5. And this guy is x minus 3 times x plus 5. So if we take out an x plus 5, what's left inside? What's left inside the big binomial? Well, there's an x plus 5 left inside, minus an x minus 3. This is the first step in what we call factor by grouping, or excuse me, it's the last step in what we call factor by grouping. So let's jump down here and see what we got. A big binomial here. The first term and the second term, what do they both have in common? They have an x minus 8 in common. So I'm going to take an x minus 8 out of each term, and in the big binomial, what's left? An x minus 8. Leave it in parentheses. Minus sign comes down, and this is gone, so what's left is an x plus 2. And yes, we could multiply this all out, but we don't need to. We'll just leave it like that. All right, one more for the good of the order. Looking at this as a big binomial, what does the first term and the second term have in common? They have an x plus 7. Take out my x plus 7, and what's left inside the big binomial? Well, there's 3 of these guys, so 2 of them are left. So x plus 7 to the second. Minus sign comes down. This guy is gone, so the x minus 2 is left inside the big binomial. Okay. All right, let's do one more of these together. Oh, let's see. A rectangle has a length. All right, let's get our rectangle of x plus 2. And it has a width of 2x plus 3. Write an expression that represents the area of the rectangle. Remember, area is length times width. So we can say x plus 2 times 2x plus 3. And now we can FOIL it out. We get x squared, 2x squared. X times 2x is 2x squared, plus 3x plus 4x plus 6. Combining the middle two terms, the area of this rectangle is 2x squared plus 7x plus 6. All right, one more for you. This one's kind of tricky. Find the area of the shaded region. Well, it's not too bad because we want to think of this as the big shaded area minus the little non-shaded area. So we'll multiply x plus 2 times x plus 2. That will give us the area of the whole box, length times width, and then we'll subtract out the area of the little box, which is x minus 1 times x minus 1. Okay, so if we FOIL this, It's x squared plus 4x plus 4. How do I know that? Well, x times x is x squared, and then it's 2x plus 2x is 4x, and 2 times 2 is 4, minus x times x is x squared, and then x times negative 1 is negative 1x, plus negative 1x is negative 2x, and negative 1 times negative 1 is positive 1. Okay, so this is the area of the shaded region. This is the area of the non-shaded region. So we have to subtract this from this, which means x squared plus 4x plus 4 minus x squared plus 2x minus 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 2x is positive 2x. Negative 1 times positive 1 is negative 1. All right, now we're ready to combine like terms. X squared plus negative x squared, it just cancels out. 4x plus 2x is 6x, and 4 minus 1 is 3. So that is the area of the shaded region. All right, guys, I'm going to leave the rest of this worksheet for you to complete. If you have any questions, let me know.